Hello, and welcome back to Into the Verse. In this episode, we continue our journey through the different types that verse provides us. In the last episode, we looked at common types, or simple types as they're sometimes known. And in this episode, we're going to be looking at container types. So, container types are kind of what they sound like. Essentially, they are a type that stores a bunch of different objects, generally objects of the same type, but not always the case. So just for demonstration here, we can see that, like in the last episode, I have this object here I've created, this constant, myInt is the name of it. It's of type of int, or integer, and I'm setting it equal to 3. Now let's say I wanted to store a bunch of these integers, right? I wanted to have 3, and I wanted to have 7, and I wanted to have 8 maybe. Now I could go through and make a bunch of objects, right? I could do myInt 1, and it's an integer, and it's going to be 0, and myInt 5 is going to be, or 2, right, if we're going in order. It's going to be equal to 9, and I could keep doing this forever. And this is fine. The program's not going to run any worse if I do it this way, but I am having to keep track of each one of these, and the naming convention is pretty bad because I don't know the difference between myInt and myInt1, and maybe I have specific reasons for all these numbers and I want to name them accordingly. But still, it seems like a hassle, right? We don't want to have to create a bunch of objects and name them all something similar if we're trying to use them to accomplish a similar goal, or maybe we want to choose from one of these randomly, right? Just doesn't make much sense. So we're going to talk about arrays. Arrays are the first type of container type we're going to learn about, and they're fairly straightforward. I'm going to start by showing you how to create an array, and then we'll go over the type. We'll go over the syntax and everything else. So to create an array, we first need to know what type of array the array is going to store, type of object. In this case, let's keep it simple and let's make our array store integers, right? We were using that as an example, so we can go ahead and continue with that example. So I'm going to call this integer array, and then I'm going to make it of type square brackets int, okay? And then I'm going to set it equal to array with some curly brackets at the end. Let's break this down. Integer array is my name for this array. It can be whatever you want. And as you can see with our last time we made a type, we just used the type itself as the name, or as the type field. In this case, we are using that still, right, an integer, but we have these square brackets in front of it. And that's telling the compiler, it's saying, hey, I want an array of integers, okay? And then in order to create that array in memory, we set it equal to an array, and it's just an empty array right now. So this is just a object, right, of type integer array that's hanging out in memory, but it has no actual objects inside of it yet, right? It just starts and ends without anything inside. So let's give it a few things to look at. Now we know the type that goes into this is an integer, so we can feed it some integers. So we could say 5, and 7, and 22, and negative 15, and whatever, 200. Great. So now we've created this array, and we have several objects inside of it that are of type integer. So it's an integer array. It stores integers. We can create them before runtime, right, before we start our program, before Fortnite starts, by using this syntax where we set it equal to an array and then put these inside. Now, something interesting to note, and that trips some people up, especially when they're new to programming, is the idea of zero-based counting. So we as humans, we naturally infer objects to an amount, right? If there's something in front of you, let's say blueberry. There's a blueberry in front of you, and you were asked to count that blueberry, you'd say that's 1 blueberry. And if there were 5 blueberries, you'd say that's 1, 2, 3, 4, 5 blueberries. Well, in the case of programming and arrays, we generally start with 0 when we're counting. And there is a specific reason for that, that we don't have to go too into. But keep in mind that when you are accessing arrays, and we'll talk about accessing things in a later video, but when we want to get at these numbers that are inside of our integer array, we need to know that the first element, right? The first element we can run into is at is at index 0. So this would be like putting 5 blueberries in front of them and asking them to count how many, and they'd say, okay, that's 0, that's 1, that's 2, that's 3, and that's 4. Right? There's still 5 elements, right? There's still 5 blueberries in total, but the first one they counted, they equal to the number 0. And that's what we have to do with arrays. So in this case, the 5 that we have right here, index 0. This 7, which is, again, the second element, but it is index 1, index 2, index 3, and index 4. Okay, 5 elements, last index is 4. And that's important. And that becomes more important as you learn more about programming, and it'll make more sense as well when you start to use arrays rather. Now, in the integer array is not the only type of array we can create. In fact, we can create an array out of any type, including types we make, and we'll get into making our own types in the future. But let's try this out, right? So instead of an integer array, let's make an array of strings. String array. We're going to use the same syntax, except so the square brackets, and it's going to be a string afterwards. We're still going to make it equal to an array, and there we go. Just like that, we have a empty array of strings. Now let's populate it. So we can say hi, my name is Carter. And just like that, we've created a new type of array, which is an array of strings, and we have 1, 2, 3, 4, 5 elements in this one as well. And if we remember from just previously talking about this, hi would be the 0th index, my would be at the first index, name is at the second, is at the third, and Carter at the fourth. 0, 1, 2, 3, 4, 5 elements. So great. And now that we know we can create an array out of any type, it's actually time to start talking about the next container type that Verse has for us, and that is the map. Oh, my cat has decided to say hi. So let's talk about what a map is and how we can use them. So I want to take a step back before we jump right into that, and let's talk about what it means to have a key value pair, right? I'm going to write that out. Key value pair. This is a term in programming you'll hear quite a bit, especially when you're talking about maps, or sometimes they're called dictionaries, depending on the language you are using. They can kind of change names interchangeably, but in Verse, it is specifically known as a map. But you might hear people refer to them as dictionaries. So, key value pair, though, what does this mean? Well, this means that we have a key, which is a type of object which will allow us access to its value. And that's why it's a pair, right? You need the key to get the value, and they are kind of paired forever. You might have multiple of the same key lead to, multiple different keys lead to the same value, but you will still be required to pair them. You always need a key for a value, at least in the terms of a map. And we can actually kind of see that with our arrays as well, even though it's not expressed in the same way. We can look at the key value pair of an array. Let's take the string, for example. I'll make another comment on this line. I'm going to start tabbing over here just to show what I mean. So in the string array, we know that the first element we run into is index 0, right? Now, our key value pair in this case is an integer, right? We have to use an integer to get at the first element, index 0. So our key would be, I don't need this, is 0. And our key for my is 1. And our key for name is 2. And our key for is 3. And lastly, our key for Carter is 4. So if I were to plug any of these numbers into this array, we would receive this element, right? This data. So maps work in a very similar way, except they allow us to define the type of key we use, right? With arrays, we're bound to integers. We can only use integers as the key. We can put anything we want as the value type, but we must use integers as the key. with maps, we can use any type as the key and any type as the value. What do I mean by that? Let's see it in action. So I'm going to make a map, and I'm going to call it, let's flip the script here, right? We're using integers to get at strings here. Let's use strings to get at integers. So I'm just going to call it string int map. Not a great name, but it is a name to show off what I'm doing here. To define a map type, as you remember with arrays, we did like square brackets and then the type it's holding. We're doing a similar thing, except we're going to tell it what type of key and what is the type of the value. So first, to define the key type, we'll use square brackets, but inside of those square brackets, we'll give it the key type. In this case, string. And then the value type is going to be int. So you can do it right after like this. And we're going to set it equal to map. Just like that. Just like we made an empty array earlier by just having the array with square brackets, we're using a empty map here. So this is a map of string int, right? That's the key value pair, string int. In fact, so we can remember this, I'll move this over. So it's kind of lined up at least. So key value pair. It's a pair. Let's talk about how to actually put some data inside of our map though, right? So we want to be able to use a string, and we want to be able to feed it into our string int map, and we want to get an integer back. So to define that, first, kind of like the array, we're going to use commas to separate each one, but we need to define, instead of assuming that the map is going to start at some element or index, right? Like the array always starts at 0. Well, the map doesn't really start anywhere. It only knows how to get its information by the key that you feed into it. So let's start by making a key. Let's start by making a key of, we'll just call this key, exclamation mark, right? That's our string, and that is our key. And now we're going to say what type, or what integer it is the value pair of. So I'm going to put an equal sign and a right arrow, an alligator bracket, the greater than sign. And then I'm going to give it an integer. Let's say key is equal to 5. And you can see we cleared up all our errors here. And the reason is we have successfully loaded one element into our map, right? One key value pair now exists inside of our map. The key is key, exclamation mark. Exactly like this with the capital K and the exclamation mark. And the value that's going to be given to us if we were to put the key in is 5. Let's make another one. I'm going to do random letters. And it's going to be equal to 27. So now, if I wanted to access this element, 27, this value, I would need to load in LKJFL. I'm not going to read it all, but these string of letters would give me this value out of this string int map. Okay, cool. So now you can kind of see how we're loading in, how these are related, right? Instead of using an integer as the key up here, essentially, we're using a string as the key, and we're getting integers. Now, it doesn't have to just be integers and strings. Just like the array, we can kind of make it out of anything we want. So let's do one. We covered characters in the last session. So let's talk about characters and maybe what should our value type be. Let's do characters floats, or better, let's do floats as the key and characters as the value. So I'm going to do float char map. Float char map. Again, in my square brackets, I'm going to put the key type, which will be a float, and then a char will be the return. I'm going to set it equal to an empty map. And what is it not liking about this? Here's a problem I didn't foresee. So currently with verse, we can't use floats as the key for maps. That's all right. That's just a limitation of a new language. I'm sure they'll address this in the future. It's a little unfortunate that we can't use this because it could be useful in some cases. But for now, let's figure out another type. So we're using strings and ints. Let's use, what's another common type we ran over? We could use booleans, right? Or logic, sorry. But the problem with this type of key is that there's only ever two states, right? Logics can be true or false, nothing else. So if I were to try to do this where I had a logic and a character, logic as my key and a character as my value, I could say, true, and that would be equal to the character A. And I could say false is equal to the character B. But that's it, right? Those are the only two ways a logic can be, true or false. So what would happen if I were to try to load in true again? Let's find out. If true is equal to C, well, this doesn't make sense. We have the exact same key in two different areas, but they're giving different values. What would happen here? Well, I'm not sure, actually. I don't know how Verse would handle this, but I don't think it would be pretty, that's for sure. And maybe at the end of the episode, we can find out what happens if we try to extract the character from this and see what it spits out at us. So just know that using a type as your key that is more versatile than something that can only be in a binary state, true or false, is useful. Maybe there's a use for this in the future that I can't foresee right now, but right now I can't think of why this would be useful. All right, let's talk about the next type of container type that we have. This is going to be a option. All right, options are a little confusing at first, maybe more confusing than our array and our map, but we've successfully kind of explored those. So let's see if we can't talk about the option. There's a reason it is called an option, and that you don't really reference it, the word option, until you are setting something, but we'll talk about why that is here in a sec. So first, to define an option, we're going to need a type that's going to go into the option, just like any other container type, right? An option is something that contains another object of a type. So let's talk about an option with let's use a logic as the value inside of it. No, logics might be kind of confusing. Let's use an integer just to be safe. So let's say my int option, okay? And to define the type of an option, we're going to do the colon, and then we're going to do a question mark first, and then the type itself. So question mark integer, int, and it's going to equal, well, there's two things it could equal right now. We're going to start by it equaling false. Now this might look a little confusing. Let's break it down. My int option is the name. The question mark before the type denotes that it is going to be an option containing that type, so an option of integer. And we are setting it equal to false. Now you might be saying, hang on, I thought false was a logic, right? It's a true or false, and that is correct. Logics can be true or false, but options can also be false, but they cannot be true. And the reason why is I'm going to name this my int option 1, and I'm going to make a duplicate of this line and make it my int option 2. And if I were to now try to store a true value in here, we're going to get an error. You see, it's not liking it. Let's see why. This variable expects to be initialized with the type of question mark int option integer, but this initialize incompatible with type of logic, right? So true is a logic only type or option. Oh, I'm using a lot of words that all sound like the same. True can only be part of a logic. False can also be part of a logic or an option, right? False can be used here or here, and not just with integers, but any type that an option is. So let's show how to properly load an option with a value. We know that it's going to store an integer of some type. Now, to actually put an option in, we can't just put 5. Now, you might say, well, I want to store an integer in there. Why can't it be 5? 5 is an integer. But that is not of type option integer. It is only of type integer. So to store an option, we're going to type out option, like the word. We're going to put these curly brackets, and we're going to put a number inside of it. And now my int option 2, right, our second version here, is equal to option. Equal to option 5. The reason this is useful is sometimes you want to know if a value is populated or not before you do anything with it. So in the case of my option 1, it's false. If I was to try to extract the integer out of my int option 1, it would not work. I would get false. If I were to extract the integer out of my int option 2, I would get 5. And the reason we have to do this is sometimes things want to give you a option, and you need to check whether that option has essentially succeeded or not. Let me give you an example. If I just try to let's see, if I were just, excuse me, I have the hiccups. If I were just to try to print our my int option 1, right, we get an error here. And that is because with this huge error line, but the top says that there's no overload function for toString that matches the provided argument's option integer. And that means that there's no way to make this into something that can be printed out. Even though it might have a number inside, we first have to check if the number actually exists. So we need to use an if statement. So we'll talk more about if statements in the future, and we did cover them a little bit in the event binding episode, but we'll be covering more about the details of the if in a future video. For now, we're going to use an if statement to check a condition of something, right? We want to know if something is essentially true or false, or in this case, if it's false or there's something inside of it. So if I were to try to just do if my number, right, is equal to my int option 1, what I would get if I then just do this is an error. And that's because this is just looking at the option itself. This is looking at the whole option and saying, well, this can't really fail. Like my number, whatever this variable we are, or this object we are creating, is always going to be equal to whatever the option is, be it false or be it an option of a number. So we actually have to drill into the option, right? That's why it's a container type. We have to dig into it a little bit to see what's in there. So I need to put a question mark at the end. And you see that fixes all of our errors. And that's because we are saying, hey, look at my int option 1, right, which is false. And then we put a question mark and say, unpack that. That's what the question mark at the end does. It says, hey, unpack that and give me the resulting value. So what would happen in this case is my number would check the resulting value, that like it would open this box and then look inside and it would see, oh, it's false, right? And if it's false, well, that means this if statement should not happen. So if my number it becomes false, we skip. We just move on, right? The code inside of this if statement will never execute because the opening the box returns a false. The if sees that it's false inside of here, and it says, oh, well, skip all this. Go straight down. So we would skip this. Now, let's say we try to open the other option we made, my int option 2. We'll do the exact same syntax, right? I'll even copy paste this right here. And we'll leave it as my number because it's different than this one. Don't worry about that for now. I'm going to clear this just in case we get a different result. Oh nope. All right, my cat was on my desk. My apologies. So I'm going to write my int option 2, right? So we're changing from this object to this object. And now, if I were to try to run this, what would happen? Well, again, we're creating my number, and it's going to be equal to the unpackaged. We're going to open this box up and say, what's inside? Because of this question mark. And, well, would you look at that? A 5 is actually inside of this option. So this if statement will check, hey, what is my number? Is it false? It's not. My number is 5. So we will happily enter here. We'll go into this if statement and do whatever code we have inside of this, right? And this can be useful because these can change at runtime if they're variables, right? So if I do var on these, that means that we can make changes to them later in the code. And we could change this from false to option whatever with an integer inside. And then if I were to run this line again, it would be true. Or vice versa, if my int option 2, which is currently loaded with a 5 inside of it, we change that to false at runtime. Then if we were go down to line 28 here, if this ran again, my number would be false and we would not enter here. We would skip over like we did previously. So that is how options work. They are a little confusing and sometimes you don't quite understand where they can be useful, but I guarantee you they are extremely useful, and you'll be using a lot of them as you continue your development journey. All right, let's talk about the next type I want to cover, and that is the tuple. Tuples are another container type. Again, a little bit confusing, but we'll walk through them here. So a tuple, you might have heard the word before. It generally refers to a set of things, and generally a set that is in order, but that is not exactly how they are used in programming. So let's show you how to make one, and then we can talk about accessing them. So here's a tuple. I'm going to call this my tuple, right? Boring name, that's okay. I'm going to set it the type equal to, and then what I'm going to do is type out tuple, the word, and I'm going to put parentheses, and then inside of the parentheses I'm going to start naming types. So let's do int, string, float, char equals, and then we need to provide it a value here. So I'm going to open the parentheses once again. I'm going to write 5 high 1.7 a. Okay, and we have suppressed our errors, and that is because I've created essentially a new type here, even though we're using a container type of tuple, but I'm creating this container type tuple, and inside I'm telling it, hey, you're going to have an integer followed by a string, followed by a float, followed by a char inside of you, and we are setting that equal to 5 high 1.7 a. Now I can use multiple types back to back or wherever we are in here, but we must fulfill every single type that we've given it, right? So if we add a new type inside of this tuple, we must equal it to a new one. If we were trying to skimp out or add too many, our compiler would complain at us. If I try to add another integer here or another character, it won't like it. If I try to get rid of the last one, it won't like it. We must have the exact amount of objects as we do as the types declare. Okay, so let's talk about accessing a tuple real quick. So we have my tuple. We know all this data is contained inside of it, but how do we get each element out of this, right? We know kind of with arrays and maps, we can use square brackets. We'll cover more of that in the future, but how do we get a type out of a tuple or an object out of a tuple? Well, we're going to do that just by, first we'll say, my element. I'm going to set it equal to, and say my tuple, right? That's the name of our tuple. And then we're going to use parentheses, and we're going to give it an integer, just like we would with an array. So if I did my element is equal to my tuple 0, that will give us the first element, right, at the 0th index being 5. So my element would equal 5. Now let's say I change my tuple to 1. Now we're looking at the second element, or the first index. And now my element is equal to high. So you can see how this might be useful for packing and storing a bunch of different data types together. Now it's easy to go overboard with this, right? It can be a little bit of a you can shoot yourself in the foot essentially by creating a tuple that is too complicated, too many types going in there. You can imagine I have this going out like, many more types for whatever reason I'm using it, right? And all of a sudden I'm like, oh, I think it's element 5, but I'm not sure, or 4, and let's just hope that works. And now my element's set to 0, 1, 2, 3, 4. My element's set to the character C, but maybe I was trying to get at this element instead, right? 1.7, which is a float. And I'm thinking that my element is equal to a float, but it's actually a character, and now my code's all wonky. Now we can guarantee that the type that's going in is only a type that can be allowed by spacing out this colon and this equal, which is kind of inferring the type, and we can tell it exactly what type I want. So let's say I wanted float. This is now going to yell at us, and it's going to say, hey, wait a second, at index 4 of my tuple, it's not a float, it's a character, right? I'm like, oh, okay, that makes sense, so this will be index 2. Oh, now it works. If I were to try to go to index 1, again, wouldn't work. 0, only 2 works here. All right, cool. Now that we've covered tuples, we can move on to, I believe, the last type of container type, and that is, we can leave that there, Ranges. And let me just double check our documentation here that I didn't miss any. Yes, range is the last type that we can talk about for container types. And by definition, ranges are generally not used outside of things that iterate through them. So let's talk about what that would mean. Like if I try to make a range, call it range equals, and then I could do, the syntax would be this. It's not going to like it. It's going to say unknown identifier. Even though range is a type that Verse recognizes, it's not one that you can create freely. All right, ranges are only used when iterating through something. So let's talk about how we might use a range in a for loop. So we haven't covered for loops, but for now, just know that essentially we are going to move from essentially point A to point B with all kind of points inside. So, if it's from 0 to 10, we'll go 0, 1, 2, 3, all the way to 10, and then we'll stop. So to kind of access or create a range, you will do first in a for loop, you'll define a integer generally. It doesn't have to be an integer, but in this case, it will be. And our integer that we want to access is called index, and it's going to be equal to 0.10. And it just wants us to put something down here so it stops complaining. But in this case, we created a range from 0 to 10, right? So our for loop would start. It'll say, hey, index, be equal to 0. And then index will be 0. And we could even print, right? We can do our print trick where we make an integer a string, and we say index. In this case, we'll loop through, and index will be 0, so it will print 0. And then at the end of this code block, we'll say, hey, have I finished all my loops yet? Am I at 10? No, I'm only at 0, so let's go to the next one. So this starts again. Index becomes 1, right, which is in between 0 and 10, and then we print 1. Then we would print 2, and we print all the way up to 10, and then we would stop. So this is a range. Again, not a type that you can just actively create, but one that is more useful for looping through things and iterating on objects you have. All right, that's going to be it for this episode. Again, we've covered arrays, we've covered maps, we've covered options, tuples, and ranges. And I think I was going to do something with one of these earlier, but I can't remember. I'll see it when I'm editing, and maybe we can do it in a future episode, but that's okay. For now, thank you so much for watching. If you're enjoying these videos, if you think they're informative, if you'd like to just support me, please just consider liking and subscribing to the channel. It's keeping me motivated. I've saw some comments on a previous video, and they made me happy, and that's a great feeling. So if you are enjoying, please consider liking and subscribing. Other than that, thank you so much for watching Into the Verse. I will catch you next time.